好的，接下来我们邀请到的第二位嘉宾的话是 Linden， 他是来自 Whisper 的工程部的负责人，他有13年言语处理和语音信号领域的研发经验，曾经任职于 Nest、Google、Global IP Sound 等公司，拥有瑞典查尔姆斯理工大学的电子工程硕士和博士学位，发表超过25篇论文及多项专利。那么对于 Whisper 来说，可能我们国内的很多小伙伴可能对于 Whisper.AI 的了解并不是很多。那它这一家公司是2017年成立于美国硅谷，是目前我们可以知道，就是说所有的新品牌，就我们不说第一梯队的这个6大品牌的话，6大品牌之外，它是在所有的新品牌助听器中第一家声称自己是在产品中运用了 AI 的技术，并且在2020年的一个 B 轮投资，它获得了3500万的一个投资额。所以说的话，那因为那个Linden先生他现在是在美国，那么所以我们还是按照以前的方式，先采用录播加中文字幕的方式来进行一个分享。那么这一次我们并没有事先准备一些 Q&A， 所以如果大家有一些疑问的话，可以在留言区留言。那后续的话，我们会跟他们美国公司的同事进行一个沟通，他们后面如果有回答的话，会在我们公众号的文章里面给大家进行一个解答。那现在我把屏幕切换过去。
Hello, my name is Linden. I am head of engineering at Whisper.AI, and we're a company that bring new technology, in particular artificial intelligence, to hearing care. I am very excited to be here today and talk about how we can go beyond the simplistic frequency analysis we used to in today's hearing aid and get a much better experience by using artificial intelligence. And I'd like to start, though, to thank the Beijing Society of Audiology for inviting me to give this talk. I'm really, really excited to be here. Hearing care is something very personal to me. I have many friends and family that are suffering from hearing loss and not getting the experience that they would like to, and that I know is possible. And I'm going to talk more about that, and in particular on how we here at Whisper are addressing this. But let's start with where artificial intelligence is today. It reminds me a lot about what was happening to the internet. So let's go back to, say, 1995, when the internet was definitely around. People were starting using it for a lot of things. But I don't think many of us had any idea how quickly it would grow and become so important. So today, the internet is everywhere. It's invisible. We touch it all the time. You don't even think about it. It's just there. And the same thing is happening to AI. Right now, we see it proliferating all over our daily lives. Take your favorite assistant like Siri or Google Assistant, etc. And that's a great example of artificial intelligence being very, very helpful. You have all kinds of smart devices in your home using artificial intelligence, and all over the internet. Of course, there are smart algorithms helping you find what you want. And but still, there are gaps. There are places where it's not being used, and hearing care is one of those places where artificial intelligence can be used to really improve the experience, but we're not there right yet. So, or at least we haven't seen it much until now. So let's talk about some of the key concepts here. I'm not going to go into all the details of artificial intelligence. I know other presenters are talking about that, but one of the key things that I think is really important to focus on is what we call the learning cycle. And what it starts with, you of course need a AI algorithm, which is a really powerful tool to do things that solve very complex problems and can be really take on things that we couldn't do before. So that's the first step in the learning cycle. Next step is this improved performance that it gets. So the end users see a much better product, and it's solving challenges that we couldn't solve before. And what's really great about what's happening is that we learn from this. We get new data, and these new data points can then be fed back to train and retrain the artificial intelligence algorithms. And this is the cycle that keeps making the performance better and better, because we have something good, we get more data, and we use that to improve the algorithms. And we really believe in this here at Whisper. And I'm going to talk about how we have done this. We have taken AI to our heart, and that's the focus of what we do. So let's see how that works in our approach. So the first thing I want to talk about is why AI is capable of delivering so much better performance. And we'll go into some examples on why current processing is limited to fairly simplistic frequency analysis, and AI can go much further than that. And as I mentioned before, the learning cycle is a really important part of this. So having algorithms is a great start, but then being able to train them and upgrade the system is really, really key to this. So that's, in our design, that was a very key part of how we designed our system, to make it upgradable, so you can keep following the learning cycle and improve, so the experience gets better for every day. So let's look at traditional processing in hearing aids. You're all familiar with compression, gain management, everything that goes into a regular hearing aid. There hasn't been a lot of changes in what's done over the years, but inch by inch, the performance is getting better. But what we're looking for here is a much bigger step than that. So let's look at the key problem that the current algorithms aren't solving very well, and that's processing speech in noise. If it's a silent environment, the hearing aids do pretty well, but when you have background noise, that's when they really struggle. And that's the specific problem we're trying to address with artificial intelligence. So here is a spectrogram showing a voice in the presence of some background noise. And I've highlighted some areas of speech activity that we can see out of the spectrogram. And let's see what our traditional methods will do with this. First of all, it typically looks at something similar to the spectrogram, but with a pretty limited view of seeing the complex patterns that are in here. So a traditional, fairly simplistic method, I'm taking a little bit of a oversimplified example to just show the point we're doing here. So one way of enhancing the experience in this would be to look at some different frequency bands. So you have a frequency band here, 500 hertz to 3.5 kilohertz, which is very active in speech. So we can try to enhance that, and at the same time we reduce the gain for the higher frequencies where there is more noise than speech. And the result is then something that looks something like to the left here. It's clearly more, you see more of the speech, but there's still plenty of noise, and you enhance the noise in the frequency speech regions, but you've also lost a lot of the voice in the high frequencies. So let's look at how artificial intelligence can get us to something like the picture to the right, which is really enhancing just the speech, and all the noise in the background is suppressed. So this is what we expect to see. And you can even see that there are speech parts here that we didn't see before. But let's dive in a little bit on how you do this and why artificial intelligence can be so, or is needed for this. And to start with it is how complex the sounds we're trying to analyze are. If we just look at it as a source and an environment. So sources can be many different things, and that, for example, someone talking, an appliance, loudspeakers, emergency vehicles, all the sounds around you. But of course, each sound also sounds different depending on what environment it is in. So we have this complexity of combining all of the different sources with different environments. So let's start looking at the sources. And even if we just try to describe them in very simplistic terms using a few parameters, we see that there are many parameters that define them, like the pitch of the sound, the frequency, volume, and what type of signal, what's the harmonics in it, the complex patterns, is it repetitive, what kind of signal it is. So a lot of different ways you need to describe each sound. And on environments, it can be anything from, you can be outdoor with wind noise and all kinds of noise there, but also no reflections. But if you're indoors, you have a room where you have the sound reflecting on the walls and floors and ceilings, and how that impacts the sound is really dependent on the size and shape of the room, the type of materials on the different surfaces, if there are other objects, etc. So basically, we have very, very complex sounds, and we're trying to, in this, find the sound that we're interested in. And this is why the simplistic methods really don't work that well. So let's talk about what we call the Whisper sound separation engine. And that's what we created to solve this problem and try to separate the sound from the background noise. So back to the example we looked at before. What our speech separation engine is trying to do is to find areas of high importance in terms of speech. So it's analyzing at a different level, not just simplistic frequency analysis. It uses all the knowledge we have given it through training of these complex sources and environments to figure out what is the signal of interest here. And then we can enhance those. So you can see, for example, as I mentioned before, there are areas that we didn't even see in the presence of noise before that are actually important speech areas. So for example, here, there is a high frequency speech that we would have completely killed with the simplistic approach we took before. But here, the AI engine has found that speech and it is enhancing it. That said, I'm not saying that artificial intelligence is the only solution to these problems. Actually, to the contrary, it's the combination of artificial intelligence and traditional methods that give you the best performance for the processing, the amount of processing needed. Because one of the things with artificial intelligence is that it typically requires a lot of processing, while traditional signal processing methods are very capable of doing certain tasks at a very low power consumption. So when we combine them, we are able to really highlight everything we want and get the best possible performance. So examples are, you can start to even, you only turn on the artificial intelligence when you detect there is noise with a pretty simple scene analyzer. You can increase the spectral noise reduction different levels to figure out based on what the signal looks like. And you can use things like directional microphones to hone in even more on the signal you're after. So, we at Whisper, we have launched the first hearing aid with on-device artificial intelligence. And let's now focus on how we built that and how it works. So there are two pieces to the puzzle here. First of all, the earpieces. And the earpieces we have designed are very traditional in terms of having all the things that you expect from a premium hearing aid. There is the compression, gain management, feedback manager, directionality, and regular noise reduction, and all the things I talked about that you need to complement the artificial intelligence with. So this is the good starting point, and these work as normal hearing aids, premium hearing aids. But what makes them stand out is when we add the Whisper Brain, which is a additional device that you can bring in your pocket or your purse or whatever. And that's where the artificial intelligence is running, the sound separation engine is running on this device. And I'll talk about why this device is necessary and what benefits it gives. And so, as I mentioned, you can use the hearing aid as it is standalone. You then have a perfectly great experience as any other premium hearing aid. But again, it gets even better when you combine it with the Whisper Brain that runs the sound separation engine. So you can bring it with you when you need it and get this boost of performance. You may not need it all the time if you're in a quiet environment, and then you're good with just earpieces. So the obvious question is, why didn't we put the AI into the earpieces? And let's look at why. And the first place to start with is, how do we do all this processing? So we have these advanced processors that can help us process sound, and they're really capable, and they're all kinds of sizes. And the way you typically measure the performance is how many operations per second you can achieve with this processor. And of course, the more you can do, the better, but it also comes at a higher power cost and size cost. Let's look at what a typical hearing aid has in terms of processor. So here we have a very traditional premium hearing aid with a few million operations per second, 1 to 2 or so, and it keeps growing. For every generation we get a little bit more, but this is the rate with the growth of how much processing power. You double it in a number of years. It's not something that is increasing very fast. So let's look at the Whisper Brain. What do we have there? The processor we have there is a lot more capable. Actually, 300 billion operations per second instead of a few hundred million. So if you go back to this graph I had that showed what we have to the left here on a traditional hearing aid, that's dwarfed by what we have on the Whisper Brain that you see to the right in the blue. And this is what gives us the ability to really leverage the artificial intelligence to its best by having all this processing power. So we talked about the learning cycle and how we apply that to hearing care. You can what you have to have is the processing capability as we have on the brain, and you need an ability to update the engine, which we can do, and you need to collect data. And all of this we can do in the system because we have the very capable brain combined with normal earpieces. We have a connection to a phone that can take care of data and connect so we can do updates. So basically, again, we run a large AI engine on the Whisper Brain, We have the connectivity to update software, upload data, and also have the memory so we can store this big AI engine and also collect data that we can then use to train and improve. It's of course important to be very careful with the data so we know sensitive information is ever leaving the device, and would of course not record audio per se, but we can still learn in a lot about the scenario we're in and make a much better experience. So again, just want to iterate the importance of processing power, connectivity, and the ability to handle data. That's the learning cycle, and that's how the artificial intelligence can really get better and better over time. And yeah, here in a different way, basically saying the same thing. AI algorithms, you get better performance when you get new data. So let's talk about the data. What kind of data are we looking at? There are three kinds of data. One is the patient experience and clinical experience. It's very different from the AI algorithm in itself running, but that's data that we can use to keep improving the performance. And then more directly involved in the AI engine is all the information we get about sound sources and environments, and we keep collecting data and use this to train better and better models based on the experiences in real life. Just to give you a sense of how this all started for us here at Whisper, here are the co-founders of the company out on the streets of San Francisco recording noisy situations with speech. And that's where we started. Then we have really learned how to do this at a higher level. We've published papers and even made some of our data available as open source for anyone to use. And we keep working really hard on getting better and better and more representative data. And that's how we can keep improving the performance. So all of this comes together in the Whisper hearing system. In the end, it's all about the impact to the user. So let's remember that it's not about the algorithms per se. It's delivering a better hearing outcome for our patients. So we use AI to bring new processing capabilities. We use the data we get to improve it, and the patients will keep getting a better and better listening experience. And this system, as I mentioned, has already been released and is available. So this is artificial intelligence is available in the Whisper hearing system today, and is capable of getting a much deeper analysis of the signal, finding patterns that traditional methods and very simplistic frequency based resolution algorithms can't do. So that's where I like to end this. I have, as a summary, gone through what AI has the potential to do, how we have applied artificial intelligence and the learning cycle to our Whisper hearing system and been able to deliver something that is significantly better than what was there before. So I'd like to thank you for your time. And if you have any questions or are interested in learning more, just contact us at hello@Whisper.ai. Thank you for your time. It was a pleasure presenting this to you.
非常谢谢刚刚今天 Linden 给我们做的一个分享。那就像我刚才说的，我们是没有一个 Q&A 的环节的，所以大家可以继续在留言区一个留言，然后我们来做一个回答。 Whisper 的聪明之处的话，就是在于它引用了一个独立的设备叫 Whisper.Ai 来承担这个 AI 部分的运算。虽然对于说他们到底是使用机器学习还是用什么更具体的一个技术分类， Whisper 并没有做更多的解释，但是对于它的整个运算的思路跟逻辑，他们还是做了一个非常简明了的一个介绍。相信对于我这样子一个非技术的人员出身的人来说，看了这样的演讲的话，会比较清楚的了解说，如果想要一种更快速的方式把 AI 技术放在我们助听器上，应该怎么去实现，通过今天的演讲还是可以获得一个比较简单的一个理解的。那包括 Whisper 这边的话，我可以给大家简单的讲一下，就是说Whisper 现在他们的销售模式是$139一个月，但是它能够提供线上的服务，包括在线下的一个验配师的一个服务，同时这个产品是可以通过软件不停的升级，所以这个也是 Whisper.AI 这家公司除了说在产品上面有一些很独特的想法之外的话，它在它的整个销售模式上面还是做了蛮多的创新，所以这是为什么它在 B 轮能够拿到一个3500万美金投资的一个主要的原因。那么关于它更多的一些情况，后面也可以大家关注我们的公众号，获得更多的一些了解。